So today we're going to cover mountain building, the vast catastrophic deposits of the Earth, missing time, which is an interesting problem, and paleocurrents. Paleo just means old, and currents is when we look at rocks, we can often see which direction the water was flowing when it deposited that sediment. And so you find fossils of these ripple marks, and those tell an interesting story. And then I wanted to talk a bit about why this matters. I'll talk about Roger Morneau's report of what a priest said about evolution. Okay, so if we Google how much does Everest grow each year, you get a variety of answers. One of the answer that pops up at the very top is 4 millimeters per year. Another answer, a close second, is 2 centimeters per year. So that's vastly different. If you ask what the erosion rate of Everest is, that's a little harder to figure out because you have to measure the amount of sediment coming down the rivers that come off of Everest to figure out how fast it's eroding. But the answer that you'll get is about 2 millimeters per year. Okay, but to backtrack a bit, these are the Rocky Mountains, and they are beautiful and have several peaks over 14,000 feet tall. It's a pretty impressive mountain range. I remember flying over it when I was a kid and being just really admiring how beautiful it was and how immense the range was. But then later I flew over the Andes, and the Andes just dwarfed the Rockies. I took this picture out of a bus window at about almost 16,000 feet. And it's 11 degrees south of the equator in the tropics, but there's snow on either side of the highway. And the peaks closest to here, I think, are about 19,000 feet. And there's a 20,000 foot peak not too far away. And just the bulk of the mountain, there's so much more material in the mountain than there is in the Rockies. But the Andes Mountains are dwarfed by the Himalaya range. This is not Everest. And the height changes when you ask Google because the height of the mountain actually does change. When I was a kid, it was 29,028 feet, and I think now Google will tell you that it's 29,032 feet. And that's because it actually has grown. Now, something interesting about Everest, there's a limestone at the top of Mount Everest, and it has shells in it, fossil crinoids and some other fossil organisms. And those organisms lived under the ocean. So what we know about Everest is that peak of the mountain actually used to be ancient seafloor. So somehow some geologic process lifted that several miles into the sky. And we can see that happened when the tectonic plate that India sits on crashed into the tectonic plate that Asia sits on. And it just drove those mountains up. And if you look at a map, like a topographical map, you can see that it's a bunch of wrinkles in between India and Asia. Here's where it gets interesting. So if we go with the really low growth rate of 4 millimeters a year, Everest is supposed to have gone up over 40 to 60 million years. People try to shorten it for the reasons that you'll see on this page, but it doesn't really work. So let's go with the shorter of 40 million years. 40 million times 4 millimeters comes out to 160 kilometers. That's 100 miles. To give you some perspective, the International Space Station orbits at 254 miles of altitude, I think. Now, if we go with the growth rate of 61 millimeters per year, which was measured by GPS a few years ago, that's 2,440 kilometers of growth in 40 million years. And the Earth is only 12,742 kilometers across. Okay, the growth rate based on historical measurements, so going from the earliest measurement about 177 years ago to now, gives you about 56.7 millimeters per year. So that GPS measurement may be pretty close to the truth. And I wouldn't expect it to be the same every decade, for example. I would expect some variation in the growth rate, decade to decade. And then something else that we need to think about is the erosion rate. That with that 2 millimeter per year figure, that's going to give you half of the growth rate of 4 millimeters per year. So that's going to be 80 kilometers, or about 50 miles. So that would mean that in 40 million years, 50 miles would have been eroded, and probably over 2,000 kilometers would have been added. Well, we can see that that old seafloor is still sitting up there on top of that mountain. It hasn't been eroded away yet, right? So we can look at the mountain and we can see, okay, there has been some erosion, but that ancient seafloor, it got lifted up and it's still there. There's no way that there was 50 more miles of sediment on top of that to get eroded away. And yet these are measurable values. We can measure these and we can see that this is not actually, like, the math is not adding up when you try to count 40 million years. What does add up is the idea that during the flood, these processes were much accelerated, and they've been kind of waning ever since. All right, I want to look at vast catastrophic deposits. The area that's outlined here in the light green, you can see North America. That is where the Tapeats sandstone we can still find Tapeats sandstone. So if you go into the Grand Canyon, the Tapeats sandstone is this layer kind of down toward the bottom of the canyon. It's a very hard layer, which is why it's still there. You can see that the rest of the cliff is eroded away, and that hard layer is still there. And the Tapeats sandstone, I apologize for this picture. I took a screenshot of a poor quality video from a very long time ago. But you can see a person standing next to the Tapeats sandstone, and there's a boulder in the sandstone next to the person, kind of outlined by those 3 green arrows. That's how big the boulder is compared to the person. And think about how much energy it would take to move that boulder. So if we go back to here, that sandstone, it was deposited with a tremendous amount of energy, and which means it's catastrophic by definition. And so we have that area, and that's just what's left. There would have been more if it hadn't been eroded away. But so we can see that whole area was deposited just in some enormously energetic event. So this one is quite a bit smaller. This is the Coconino de Chelly sandstone. But still, it's huge. It's covering parts of 4 states. And something important is that this sandstone, so the Tapeats is down low in the what we call the Phanerozoic part of the geologic column. In other words, where life begins in the column, that's about where the Tapeats is. Like, so that would be kind of the beginning where the flood was starting to deposit these animals that died in the flood. At the very beginning, that's when the Tapeats was deposited. Come up a ways, and we get the Coconino here. And it's smaller, but it's still huge. Oops. Okay, we got the Chinle Group of the Morrison Formation. Again, huge. The Morrison Formation, there's a lot of dinosaurs in the Morrison Formation. And something I want you to notice here is, look at that black area where the Mississippi River is. So the Mississippi River, that's a modern deposit. You can see how big that substantial modern deposit is compared to the Morrison Formation and the Chinle Group. So I just look at this. So that's the main point of this slide, is look at the size difference between modern deposit and ancient deposit. And to give just kind of a visual, the brown area would be the size of the Coconino sandstone, and the green area would be the size of the biggest river delta on Earth right now, which would be the Ganges River Delta. So the takeaway there is that toward the bottom of the geologic column, these layers are vast, catastrophically deposited, And then as you move up the geologic column, the layers actually get smaller until you get to the very top of the geologic column, where we have very local deposits. So that is not compatible with uniformitarianism at all. That means that there's been a huge break, a huge difference in the processes that deposited these rock layers that we see when we go to these national parks, or just drive through Arizona or Utah. A huge difference between the deposition of those layers and what's happening on the Earth right now. And that difference included a lot of catastrophe and a lot of water. Okay, paraconformities. That's what I meant by missing time back previously. And what happens is when two rock layers are laying on top of each other and they look like it doesn't really look like there was any time in between the deposition of the layers and there wasn't any erosion, we call it a conformity, because one layer is laying conformably on top of the other layer. But in this outcrop, we have 5 layers of rock. And in this outcrop, we have 4 layers of rock. And if you put these side by side, these may be a few imaginary hours drive apart because these are imaginary outcrops, but it shows a very real phenomenon. So notice that reddish layer is just gone. So you have all the same layers, but the red layer just pinched out and vanished before somewhere in between these two outcrops. And this happens all the time in geology. This happens over and over again between different places. So, and what's important when it comes to time is that because of fossils or because of radiometric dating or whatever, we're supposed to believe that red layer maybe was 10 million years of time. But if you look over to the right, there's no gap. There's no erosion. There's no time indication in between that kind of beige and the purplish layer. So we have 10 million years of time on the left supposed to be bound up in that red layer, but then it just vanishes without a trace. Now remember, when we're talking about erosion, remember how much like the continent would be gone in 10 million years, both from coastal erosion and from just rain. And yet there's supposed to be a 10 million year gap and it left absolutely no trace. So here we have, this is in the Grand Canyon. The lighter layer on top is the Coconino sandstone that I talked about a few minutes ago. And the reddish layer is the Hermit Shale. And there's supposed to be a 6 million year gap between the two, but that is just a flat, straight line. Now there's something really interesting right in the middle of the picture, which is why I took this picture. You can see how that white sandstone, the lighter colored sandstone actually shoots down into the red shale. That's actually, the sandstone actually got liquefied and injected down into the shale. And we can see that by looking at the composition of the sandstone that got injected down into the shale. So that's another indicator that 6 million years never happened. This is the Chinook conglomerate in the Moenkopi formation. And there's supposed to be somewhere between 15 and 40 million years in that gap between the two. There's kind of that white layer at the top of the Moenkopi, and then there's sandstone. And when we look at that, we can actually see what we call lode casts. So the rocks that make up the upper layer have actually sunk down into the mud of the lower layer before it got hard. And yet and I've actually seen the two layers kind of interfingering, where the mud from the bottom layer got pulled up into the upper layer. And yet we're supposed to believe that there's a 15 to 40 million year gap between those two in that beautiful straight line right there. Here's a gap that's supposed to be 50 million years. And again, the continent would be destroyed many times over by erosion in that much time. But Just between that lighter colored sandstone and the darker colored sandstone, there's supposed to be a 50 million year gap. There's supposed to be a 155 million year gap here. This is also in the Grand Canyon. But this happened overnight in Death Valley. So you can see how, I mean, erosion, it doesn't take much time to create significant erosion if you have any rain at all. And so when we're looking at something like this, you can see that there hasn't been any rain. There, like nothing, like literally nothing happened between the deposition of those two layers. You know, certainly nothing like that. And that was just one night of heavy rain. Okay, paleocurrents. So this is, we find rocks and we can see ripple marks in the rocks. And so we can see which direction the water was flowing. And this is an example of how thinking in terms of the biblical story actually helps science. Because if you weren't thinking in terms of the biblical story, you wouldn't ever, it would never occur to you to actually ask these questions. But when we do ask these questions, because of the biblical story, then we get some really interesting results. So here's a very quick overview of the geologic columns. So we have the Precambrian, we have the Paleozoic, Mesozoic, Cenozoic divided up into their various time periods. Now, if we look at the Precambrian, we don't see a clear pattern here. Lots of areas going lots of different directions. Now look at the Cambrian though. When you put all these data, so this was some data that Art Chadwick collected with a bunch of students and some other people, and they had over 1 million data points all around the world. And when they put this data together, they got these flow patterns that were like continental in scale. So in the Cambrian, you can see which direction the water was flowing when it deposited the rocks in general. So moving up through the geologic column to the Pennsylvanian, there's a lot of coal in this area. Cambrian, that's where the Tapete sandstone is. So Pennsylvanian, a lot of coal here. And you can see a really strong flow direction to the south. Upper Cretaceous moving up quite a bit through the geologic column. Again, you can see really strong flow pattern in a couple different parts of the United States, up into Canada. So this is not something that would be compatible. So now in the modern Earth, you know, water flows downhill, of course, and downhill varies depending on where you're standing. Water goes, I mean, the water, it trickles into streams and it runs into rivers and it flows down to the ocean. And it's a very kind of, it can be a very circuitous route. But during the flood, we had these massive continental surges of water crossing the continent. And all of this got, the record of that got fossilized into these rocks. And again, that's, you know, science is supposed to be predictive. And it's supposed to provide like the model that one uses to study nature should lead you to ask good questions. And again, this is not something that anyone ever would have discovered if they didn't believe in a biblical flood. I want to talk a little bit about Roger Morneau and evolution. I had a friend in high school, and her grandfather was Roger Morneau. And I read his books back then, and it was absolutely fascinating. And then I read it more recently, and something really jumped out at me. He had if you don't know his story, I would definitely recommend reading his books. His books on prayer or life-changing, but his personal testimony is just amazing. He was in the Merchant Navy in Canada in World War II, and he survived the war and he ran into a buddy on the street. They got invited to a seance, At the seance, they were invited to an actual Satanist society, and they joined for a bit, but God actually pulled Roger out after a few months of being in the Satanist society. And while he was there, the priest said some really interesting things about evolution. And what, he talked about, so about the year 1700, according to this priest of the Satanist society, Satan and his top counselors got together, and they came up with a plan. And the reason they needed a plan was because Satan had been reading the Bible, or he'd been studying Daniel, and he knew that the prophecy that knowledge would be increased and men would run to and fro is about to be fulfilled. And so he and his demons wanted to they wanted to come up with a plan that would take control of human minds through the upcoming Industrial Revolution. And the plan that they settled on was this three-part plan. The first step of the plan was to make people believe that Satan and his demons do not exist. The second part of the plan was to use hypnotism to gain control of the human mind. And so regarding the first part, I think it was Roger who was saying, if you walk down the street of Paris in the year 1700, there'd be palm readers and, on every corner, a lot of psychics. And if you walk down the street 100 years later in Paris, a lot of that was gone. And so the demons were actively kind of moving people away from superstition and more towards secular thinking. Now, part two, using hypnotism to gain control of the human mind, they used Dr. Mesmer to popularize hypnotism and make it part of just medical practice, common medical practice. And hypnotism is not something that I don't think we think about very much anymore. I certainly don't. But something that occurs to me is that a lot of the entertainment that people imbibe on a regular basis is pretty hypnotic. Television, music, there's a lot of hypnotic aspects to that, and I think that's pretty intentional. And then three, the point that I would like to focus on is use the theory of evolution to destroy the influence of the Bible. So they started working toward that third part. And when I read Roger Morneau's book, I was a little puzzled because, if this was Satan's plan starting, early part of the 1700s, why did it take Darwin? Why did the Origin of the Species get published 159 years later, 1859? But then I wrote a paper for class on the origin of the theory of evolution, and was really surprised to find the theory originating back in the early 1700s. So I want to, we'll get more to that, but I want to read a paragraph from the book. It said, Satan considers teachers of evolution to be ministers of his religious system, and quoting from the book, and the individual will receive a special unction from Satan himself. Satan gives him great power to induce spiritual blindness, to convince, and to convert. In fact, he holds such people in such high regard that he assigns a special retinue of angels to accompany him or her all his or her life. It is the greatest honor that Satan can bestow upon a person in the presence of the galaxy. And so I think that begs the question, why is evolution so important to the devil? A couple of key points. Evil angels manipulate people's feelings to bring them to believe certain doctrines. And the definition of doctrine that was given to Roger by the priest was any belief that brings one closer to his or her God. So one point that I want to make is that, so Satan is basically claiming all these teachers of evolution as his, and I think he likes to overstate what he owns. In other words, I think that he claims a lot of people that are not actually his. Like he tried to claim Moses. In the book of Jude, we read that, Satan thought it was unfair that Moses got resurrected because Moses had sinned right at the end of his life. But anyway, one question. Oh, sorry, one more slide here. So back to evolution being kind of started up in the 1700s. James Hutton was an early proponent of uniformitarian geology. In other words, the same geological processes that are happening right now are the geological processes that formed all of the geologic column. And it took, and they didn't know how long, but they said, very, very long time to do this. James Hutton started his work in about 1760, and he published in 1785. Now, this one's interesting. You may not have heard of Erasmus Darwin. He lived from 1731 to 1802. Notice that he died a few years before Charles was born. This was Charles's grandfather. Erasmus Darwin outlined the theory of evolution, including the origin of life, abiogenesis, in a poem published in 1802. And he had actually written out the theory of evolution a few years before that, I think between 1794 and 1796. So Erasmus Darwin came up with the theory of evolution before Charles was born. Charles Lyell, 1797 to 1875, he was a friend of Darwin. He influenced Charles Darwin and popularized uniformitarian geology, and he published his work in 1830. So by the time Charles actually published the essay in 1844, and then the book in 1859, a lot of groundwork had already been laid so that people would accept the theory of evolution. And indeed, the theory was actually a huge success. About 10 years after the publication of the book, if I remember right, it was already very widely accepted. So Satan went to a lot of work to lay the groundwork for that, get everybody ready for it, and then bring it in. And then it wasn't until 1871 that Darwin published Descent of Man. Now, what's important there is that in 1859, Darwin published The Origin of Species, but he wasn't talking about humans he wasn't overtly saying humans evolved from all of this also. He waited until 1871 to publish a book saying that humans evolved from nothing. And so if you look at the outline, just look at how all of this kind of fell together over many decades, you can see a kind of a line of logical steps kind of pushing people further and further away from the Bible until you get full-fledged evolution in 1871. Okay, I got a few minutes here. One question I had was, what was my testimony? How did I get involved in this? Why do I find it interesting? I was interested in it when I was a kid because I've always been interested in science, and my parents had a National Geographic collection, and National Geographic is kind of an evangelical tool for evolutionists. And so I would run into the stuff in the National Geographic, and then talk to my parents about it, and they were science-minded people too, and good Adventists, and they weren't worried about it. And so we had a lot of good discussions. But also been a teacher for a long time, and something that I think the reason that I'm interested in this right now is that I see that people are being pushed further and further away from the authority of the Bible and pushed toward the authority of one's own feelings, I guess. And I see a lot of people being influenced by evolution, but not even realizing that that's where the influence is coming from. Like this whole process happened gradually, step by step over, 100, I don't know, over 100 years here. And it's been pushed slowly across the world since then. And it's all happened so gradually that I think a lot of people haven't been paying attention. A lot of young Christians just kind of absorb a lot of this stuff and they don't understand what they've absorbed and how it affects their view of the Bible. Um, there's a verse that says men's hearts, talking about the end times and how bad it is, and it's saying it's so bad that men's hearts fail them because of fear. Well, what's the antidote to that fear? I mean, I would say that in order to trust that God is going to take care of us through whatever happens, um, we have to trust His word. And if the foundation of His word has been pulled out from under us by evolutionary thinking and all of the stuff that came from that, it's going to be very difficult to trust, I think. And then also, one other thing is that I think there's a lot of like in science, we should be able to ask any question. It makes science far more interesting if you can just ask any question. And the evolutionary paradigm is very restrictive. You cannot, like evolution is not, like you can't ask, where did we come from? You have to ask, if there is no God, where did we come from? And if you don't ask the question that way, then you can't even be part of the discussion. So for the sake of science and for the sake of just people's souls and their relationship with God, I think this really is a fundamental topic, even though I think a lot of people have not, I think a lot of people haven't been aware of how they've been affected by it.